Welcome to Study Loop.
So let's first write this equation. We have theta t equals 250 radians per second t minus 20.0 radians per second squared times t squared minus 1.50 radians per second cubed times t cubed. Omega t equals the first question is asking us, when does the angular velocity equal 0 radians per second? So omega t equals 0 radians per second at what t? So let's find omega t. This is simply going to be the derivative of theta t with respect to time. So this will be 250 radians per second minus 40 radians per second squared times time minus 4.5 radians per second cubed times time squared. And this equals 0. We're going to use a TI-84, TI-85, TI-89, whichever one you would like to use in order to solve for t. This is simply a quadratic. So t is equal to 4.33 seconds. This was when the motor shaft will stop at 4.33 seconds. And then B is asking us to find the angular acceleration at that t. So angular acceleration of t is going to simply be equal to the derivative of the angular velocity with respect to time. And this is going to be equal to negative 40 radians per second squared minus 9.00 radians per second cubed times time. So alpha t equals 4.33 seconds will simply be negative 40 minus, and then it will be 9 times 4.33, and this is going to be equal to negative 78.97 radians per second squared. At this point, we can say we can go on to C. C is asking us for the angular displacement at that time. So theta at t equals 4.33 seconds is going to be equal to 250 times 4.33 minus 20, 4.33 minus 1.5, well, this is squared rather, 1.5, 4.33 cubed. And this is going to be 586 radians, approximately. At this point, we can say 586 radians, 1 revolution for every 2 pi radians. And we find that this is going to be 93.333 revolutions. So D then asks, what's the angular velocity when the current is reversed? So the angular velocity at t equals 0 seconds is simply going to be 250 radians per second. So that'll be your answer for D. And then E asks us to find the average angular velocity, which should be simply 586 radians over that time of 4.33 seconds. So this is going to be simply 135.33 radians per second. This would be your average angular velocity in that 4.33 second time span. And that's the end of the solution. Thank you for watching.